Okay, this is chapter 4 in the trig. The first section is graphing the sine function. Okay, so what we're looking at is y equals a times sine, and I'm going to use this notation, bx. Okay, and for right now, we're going to focus on this and this, and then we'll add to it as time permits as we go on. The sine function, first of all, goes on and on and on, and the sine curve, one period, which we're going to do, and I always do one period to the right of the x-axis, but it continues on. So I'm just going to show you what it looks like, and then I'll fill in some things as we go. This is the sine curve. You'll notice that it is a curve that starts at 0, 0 and ends, I'll tell you in a minute, but that it is a curve. It is not a spike. It is not a spike down here. It has no points that have corners. It is simply a curve. It does touch the x-axis in 3 points. Okay? Since sine is circular, it means that its functions from 0 to 90 have certain values. And then from 90 to 270, they have the same values, only the sign may change, correct? And then from 180 to 270, same values, only the signs change. And from 270 to 360, only the sign changes, okay? Now, I'm going to tell you that everything we're going to do is in radians because it's easier to graph in radians. Okay, and if this is a normal sine graph, this is 0, okay, this is pi over 2, excuse me, this is pi, and this is 2 pi, all right? So sine is 0 at 0, pi, and 2 pi, and you'll notice that 0 and 2 pi are the same because on 0 degrees and 360, this is 360, this is 90, or excuse me, 180, right? Do you remember that? Mm-hmm. Okay. Now, if you'll also remember that sine, right, has its highest value of 1 at what degrees, if you remember? Where is sine 1? 90 degrees. So this right here is pi over 2. You understand it? Which is 90 degrees, correct? Mm-hmm. Okay, so this right here is 1, right? Okay, and this is called amplitude, which we're going to talk about in a minute. All right? And where is pi the lowest? In other words, what's the lowest value, excuse me, not pi, what is the lowest value, no wonder you're looking at me like that. What is the lowest value that sine can have?
0.
No.
-1.
-1. And do you know where it's at a -1? No, it's not negative in the first quadrant. It's not negative in the second quadrant. Okay. Yep.
Fourth quadrant?
It actually is between the third and fourth quadrant. If 90 degrees is where it's the highest, 270 degrees, which is 3 pi over 2, is the lowest, and it's at a -1. Correct? All right. Now, when I ask for amplitude, A gives you amplitude. Okay, the number in front is our amplitude. And I'm going to tell you this right now. Amplitude is always positive. But what happens is you do this. Watch this. So this one's sine, it goes 1 up. Do you understand that? 1 up, because it goes up first. Now, you can make this a -1, and it would go this way. And it would still be 1, but this becomes down. Okay? Now, all of these values repeat. And I can go on, if I just continue, but it continues on this way, and it continues on this way. You see what I'm saying? It just keeps going. What we do is we just take a snapshot of one period. This is called a period. Okay, this is a period where the graph completes itself one time. Okay, and that is called the period, okay? The amplitude is always positive, that's A. The period is found using B. Now you'll notice that I didn't say that the period was B, did I? I said it was found using B. Every sine graph looks like this. However, we can scrunch it up, we can stretch it out, we can pull it up, we can push it down, we can do all kinds of things to it. We can move it, but all of them look like this. Do you understand what I'm saying? Now we can even move it left and right, where you think, well, it doesn't look like that anymore, but it really does. It's just that we moved it left and right. Okay? So what we're going to do is we're going to start with a very simple sine graph. And I'm going to show you how to find the sine. Not all of them end up this way with these certain values. So I got to teach you to find these values. Because this is the normal one. In other words, if this is 1 and this is 1, this is what it looks like. You see what I'm saying? Okay? But let's move it around a little bit. All right? So let's take, I don't want to use a tough one right off the bat. Let's take this one, number 1. Y equals 1/2 sine of 2x. Okay, now I'm going to use this example. Now, since the sine values keep repeating over and over and over, this adjusts them a little bit. All right? So here's what happens. It's very important. We know our amplitude. Our amplitude is 1/2 up. How do I know it's up? Because it's positive. Do you understand that?
Yeah.
Okay. What time does the bell ring?
55, I think.
Okay. So what we're going to do now is focus on the period. Okay? And the period is, to find the period, we take 2 pi, and I'll write it back down here. We take 2 pi and we divide it by b. I probably should have said that when I was down here. Because I said, remember, we found using b. We don't use b, we find using 2 pi divided by it. Why do we use 2 pi? Great question. If you know, why not pi? Why not 3 pi? Because 2 pi is how far it takes to complete the period. Okay? So we take 2 pi and we divide by b. b is 2. Do you see that?
Mm-hmm.
So we take 2 pi and we divide it by 2. And that is pi. You understand that? Now remember that sine did some things. It had 1, 2, 3, 4, 5 spots of interest to us, right? Well, the first spot is the same. Unless we move it left to right, it's the same. So we don't deal with that. But we want these other 4 spots. Do you understand? So what we do is we take pi and we divide it by 4. Okay? We take pi and we divide it by 4. That means, and you simplify that, that means that our intervals, these are called intervals, and I'll write that out in a minute. Our intervals are each pi over 4 apart. So the first one's at pi over 4. The second one's at 2 pi over 4, which is pi over 2. You understand it? The next one's at 3 pi over 4, and the last one's at 2 pi. Now notice that, excuse me, it's not at 2 pi, it's at 4 pi over 4. Got excited there. So it's at pi. So they're all pi over 4 apart. Do you see that? Right?
Mm-hmm.
Okay. Is everybody okay? So how did I get these? The first one was I divide by 4 and simplify. The second one I take it times 2. The third one I take it times 3. And the fourth one times 4. And I simplify them all. Do you understand that? Okay, now these are called what?
Intervals.
These are called intervals. So do I always well, divide by 4?
No. Yeah.
Yes,
Yeah.
I always divide by 4. Hold on a second. All right. Do we get that?
Yeah.
Okay. So, every time I divide by 4, and then I get all 4 intervals. This interval And this should be the same because this is where I end. Okay, you understand it. Here's the hard part. I want to put this on a graph. All right? I want to figure out this interval, this first interval. Okay? And this is the hardest thing that students struggle with. Okay? What we want to do is we want to get an approximation that is easy to graph. What I look at is I look at this. This is approximately equal to 3. Pi is 3.14 approximately, right? And so what I do is I round it to 3. That means that this is 3/4. Do you understand that? Now graphing 3/4 is not very fun, is it? So I can do that, or I can choose my graph a little differently. Remember, my amplitude was 1/2 up, right? So I'm going to go over here. Watch this, Lauren. This is where it gets tough. Okay? This is 0. That's my first sine, right? If I was to go 1, my first interval would be right here. My second interval would be right here. You see, it's pretty tight, isn't it? So what I'm going to do is I'm going to change my scale. And I'm going to say, since I have 3 out of 4, I'm going to make every square 1/4. If every square is 1/4, then I could put my first one here, because that would be 3/4. Do you understand what I'm saying?
Yeah.
So I'm going to make my square, so I'm going to make every 4 squares 1. Because this is a 1/4, and this is a 1/4, and this is a 1/4, and this is a 1/4. You understand what I'm saying?
Yeah.
So what happens now is I can put my first one right here, and I label it pi over 4. Then guys, don't reinvent the wheel. Now I know it's 3 squares, just go 3 more squares. And that's pi over 2. Then go 3 more squares, and that's 3 pi over 4. And just go pi. You see, now I have a period. My period is different than this one because B was different. Do you understand? Okay, now, everybody good?
Yeah.
Now my amplitude is 1/2 up, which works out great because 1/2 is right here. So I label it. And I'm going to label a negative 1/2. And the more you label, the better Mr. Ellis gives you points. Now I have exactly what's going to happen. You ready? Now I just draw the same curve that you have to kind of memorize. I start here, and at the first interval, I'm at my highest point. At my second interval, I'm back down on the x-axis. On my third interval, I'm down below. At the, it should be 1/2. I'm sorry. No wonder you guys were looking at me kind of weird. So this one would be right here, right? And then back. And so what it looks like is this. Now you'll notice that when Mr. Ellis normally graphs, he goes pretty fast. But you notice that I took it nice and slow because I want that nice gentle curve through there. Because all these points keep repeating, right? Over and over and over. All right, you see what happened? All right, does that make sense to you?
Yeah.
Okay, so your first question on your worksheet is what?
Y equals 3 sine of x.
Y equals 3 sine of x, right? So tell me, what's wrong?
I don't think the video can see the.
Well, can you see the graph? They can.
Yeah, it can? Okay.
Yeah.
Okay, tell me that beforehand. I was like, what happened? Did it stop? Because sometimes it just stops for no reason. Okay, y equals 3 sine of x. All right, my amplitude is what?
3.
My amplitude is 3 up. Now, if it goes down, guys, if it goes down, it looks like this. You see the difference?
Yeah.
Okay. All right, so it's 3 up, and I need the period, correct? So the period is
1.
2 pi divided by 1. So it's just 2 pi, right? What's wrong? So it's a normal sine graph, only with a huge amplitude,
Yeah.
right? Okay, so my intervals are 2 pi divided by 4, always, which is pi over 2. Do you understand that? So then my next one is 2 pi over 2. Notice I take 2 times this. Are we good? The 2's cancel, and I get pi. Now the third one, I take 3 pi times this. And the fourth one, I take, that's already simplified, 4 pi divided by 2, which is 2 pi. And this better match this. Are we good? Okay, what's wrong, Lauren? Question? What's confusing?
I don't know, the third one, did you take times?
Okay, I took this first one, but to get the second one, I took 2 times it, and the 2's cancel. Okay, Lauren? Then the third one, I take 3 times it, 3 times pi over 2. See, if you take 3 times pi over 2, it's 3 over 1 times pi over 2, which is 3 pi over 2. Okay, and then the last one, I take 4 times pi over 2, which is 4 pi over 2, which is 2 pi. Does that make sense? Yeah. Okay. Now, this is this one, only with a huge amplitude, right? Okay, take a look at your first interval, 3 pi over 2, guys. 3 pi over 2 is 1.5. Isn't? This is 3 divided by 2. We round this to 3. 3 divided by 2 is 1.5.
Yes.
Yeah, you can do halves and go 3 of them, because that's 3 halves, right? But my amplitude is huge, isn't it? Lauren, I lost you.
No, it's okay.
Okay, you good?
Yeah.
So I have to figure this out. Do I want a huge graph, or do I want to condense a little bit to keep my amplitude in check? That's the question. Because a half is not bad to graph, is it?
No.
No. So why not go 1.5 is my first period. And that would be what? Pi over 2?
Mm-hmm.
My second then is 1.5. So here's a half and here's 1. So my second one is pi. Then I go 1.5. My third one is 3 pi over 2. And then I go 1.5, which is 1.5 and 2 pi. So it looks kind of like that. Now the advantage of keeping it like that, instead of going every 3, is that my amplitude doesn't go real high. Because I let every square be 1, correct? Right? And then my first one was 1.5, my second one was 1.5, my third one was 1.5, my fourth one was 1.5. Now my amplitude is 3, correct? So now I don't have as far to go. You see what I'm saying? All right, so what happens is I start right here, and at my first one, I'm at my amplitude. I come back down, my third one, I go clear down here, and I'm back. So it looks like this. And you can see it's really hard to keep a sharp point on it, isn't it? But it looks like that. Okay?
Is it negative?
Yes. Oh, these are negative. Yeah, I put the negative right on the line, so you can't. Yeah.
You go down to a -3 then?
Yes, because your amplitude is 3 up here, but 3 down here. Okay. Now don't graph this. Are you ready?
Mm-hmm.
Don't graph this, but watch. I could have done it like this. Ready? You got it?
Hold on.
Okay.
So you just skip them in between?
What do you mean?
Then pi and the 3 pi over 2, you just don't graph on there?
Yeah, they're right here. So pi over 2 is up here. Pi, the value is 0. 3 pi over 2 is down here, and 2 pi is back to the x-axis at 0. Remember, these are y values. These are y values, Lauren. So they're going from 0 to 1, 0 to 3, and back down to 0, then to a -3, and then back to 0. Okay, now I could have graphed it like this. You ready? Mm-hmm. Okay, here we go. I could have graphed it and said, okay, I want this to be, I'm going to make every square a half, right? So this would be a half. And this would be a -1/2. The advantage of that is now I'm on a line. I'm here. Why? Because here's 1.5. So I could go pi over 2, and then I could go pi, and then I could go 3 pi over 2, and then I could go 2 pi. And some students like to do it this way. And now my amplitude, and if I had a normal amplitude, this would be the way to go. But my amplitude is 3. Watch what happens. This is 1, this is 2, this is 3. So this is 3, This is 1, 2, 3. This is a -3. So this is what it looks like. And this doesn't bother some people. It's easier for them to graph. I got a little goofy there. Okay. Do you see what I'm saying? Same graph, I just used a different scale. Does that make sense to you?
Mhm.
So it's whichever one you like. If my amplitude, Jocelyn, if my amplitude was 1, I would have gone with this one. But since it was 3, it was like, oh man, do I really want to stretch that way up there? Okay? Questions? Okay, I want you to look at the first 3 questions. Do not do the backside because it's cosine. The first 3 questions, okay?